In today's lesson, I'm going to be discussing and explaining to you the inverse trigonometric functions. So in previous lessons, we've met the basic trigonometric functions and the reciprocal trigonometric functions. And we've discussed the SOHCAHTOA to be able to calculate the sine, cosine, and tangent of an angle when you are dealing with right triangles. And we've met that the cosecant is the reciprocal of the sine, whereas the secant is the reciprocal of the cos and the cotangent is the reciprocal of the tangent. But today, I want to focus on the inverse trigonometric functions arcsine, arccosine, and arctangent. Okay, so there are two ways in which we can write the inverse trig functions. So this symbol is the equivalent symbol in maths, okay? So that means I can write my arcsine as arcsine y, or I can actually use this inverse notation, which is the sine raised to the power of -1 of that value y, okay? The same thing with arccosine and the arctangent. So what I'm trying to say is, whenever you see this symbol, arcsine, or you see this one, they essentially are referring to the same thing. They mean the same thing. So when we take the inverse of the trigonometric function, we are taking it to undo the trig function. So I will explain by using this simple example. So if I tell you that the cosine of a particular angle theta equals x, okay? If I want to find this angle theta, or if I want to undo this cosine, then I'm going to take the inverse or the arc cosine of both sides of this equation. So I'm going to take arc cosine of cosine theta equals to arc cosine of x. So this arc cosine will take out the cosine. So at the end of the day, I will just have theta equals to arc cosine of x. So again, when I take the inverse trig function, we can use it to undo the trig function, okay? So, and now why we are doing that is because we want to find the angle. So like here now, theta will be the arc cosine of this particular value x. So let's see one example. So sine of pi over 6. So from our unit circle, we know that sine of pi over 6 equals half, okay? So whenever I take the sine of this angle, I'm looking for the value. Now, if I take the arcsine of half, I'm asking the question that what angle will give me half when I take the sine of it. That is, if I take the sine of an angle and it gives me half, then what is the angle? So that is why we are using the arcsine. So now I'm interested in finding the angle back. Of course, this is pi over 6 if you are in the first quadrant. So whenever we take the arcsine of a particular value, we are looking for the angle. In this case, this angle is pi over 6 or 30 degrees, okay, or 30 degrees. And I hope this clarifies what inverse trigonometric function is for you. Thank you so much. Please remember to subscribe.